This presentation concerns number 7 in assignment 5. We are going to make an example thereof, and the topic is geometric distribution. That's for math 1 to 2. It says a school is holding a competition where the chance of success is claimed to be 1 in 20. The cost of entry is 60 pence and the prize money is £6. You are only allowed to win one prize. So part E is asking, what is the probability of a student winning and making a profit? And part B is asking, what is the least number of attempts a student must make in order to be 60% certain of winning? So here's the example that we are going to discuss. A school is holding a competition where the chance of success is claimed to be 1 in 10 now, and the cost of entry is 80 pence, and the price is £15. And you are only allowed to win one prize. So part A is asking, what is the probability of a student winning and making a profit? So here's the solution beginning. First, we have to establish what does the term profit mean? Profit is basically revenue minus cost. Here we are using capital Pi for profit because capital P is already used for probabilities. And pi now is the symbol that the Greeks use to denote the sum P. So we can use pi for capital Pi for profit. So profit is revenue minus cost. R for revenue, C for cost. Now, from the student's perspective, from the student's viewpoint, their profit now is given by their revenue, which is the £15 they're going to win, minus their cost. Their cost is a variable cost. It depends on the number of trials, 80 cents per trial. So their cost would be 0.8 times R, the number of times that they try. Now you want a positive profit. So therefore you want your revenue to be greater than your cost. Okay, you want your cost to be less than your revenue. And we can solve for R. R would be 15 divided by 0.8. So you want your number of trials now to be less than 18.75. You want your number of trials to be less than 19. Now, number of trials, that's discrete. Less than 19 is the same as less than or equal to 18. So if you go to the unit 5, less than or P of X less than or equal to R is 1 minus Q of R. So this is the rationale for converting less than 19 and rewriting it as less than or equal to 18. And this is okay because 18 now, if the student win on the 18th trial, they will still make a profit. It will be small, but they will still make a profit because 18 times 0.8 is less than 15. Okay, we can actually prove it. $14.4. So really and truly, any value less than 19 would make a profit. Less than or equal to 18 is the same thereof. And that would be 1 minus Q to the R. Q is 9 over 10. Because remember, the probability of success is 1 over 10. So the probability of failure is 9 over 10. And the formula is 1 minus Q to the R. R here would be 18. So there's an 85% chance, basically, that the student winning and making a profit. It's pretty high from the school's point of view. And the reason is that the probability of success is high compared to an example in the unit 5. one exercise, I think. Let's check it out. There's a similar question in Unit 5, and that would be number 8, and the answer is 0.166. And the reason why it is small compared to our answer is because the probability of success is 1 out of 50. 1 over 50, that's relatively, comparatively small with regards to our 1 over 10 in this example. Now, part B now is asking, what is the least number of attempts a student must make in order to be 75% certain of winning? We have to translate what it means, or symbolically the term certain of winning. Certain of winning is winning within a time frame, within a number of trials. And this can be symbolically translated as P of X less than or equal to R within a certain number of trials. And previously, we have seen that this is equal to 1 minus Q to the R. Now, further analysis will show that you want this probability value to be less than whatever that value give you with regards to the number of times that you tried. Okay? To be 75% certain. Okay? So therefore, now that's 0.75 less than 1 minus 9 over 10 to the R, because Q is 9 over 10. And a simple little bit of algebra, you add negative 9 over 10 to the R to cancel out negative 9 over 10 to the R from the right side. It becomes positive 9 over 10 to the R on the left side, and to cancel out 0.75 from the left side by subtracting. And here it is on the right side, subtracting from 1, and that will give us 9 over 10 to the R less than 0.75. And we can apply logarithms to solve for R, because R here is an exponent. And we take natural logarithms on both sides as logarithm to the base of E, and apply the property of logarithms, whereby the ln of 9 over 10 to the R is the same as R times ln of 9 over 10. And this is less than 0.7, ln of 0.25. Now to cancel out, we divide by ln over ln of 9 over 10. Now ln of 9 over 10 is a negative number. The logarithm of a negative number of a decimal is a negative number, meaning that the power is a negative value. Okay, 1 over. In exponential, in indice realm, in indice questions, negative exponent means 1 over. And that will give you a decimal. Because remember, the base is 2.7, which is a value greater than 1. So therefore now, when you are dividing by a negative number, you basically have to switch the inequality sign, the direction thereof, and we are left with ln of 0.25 divided by ln of 9 over 10, and that will give you R to be greater than 14.2. R must be equal to 14. So at least 14 trials to be 75% certain of winning.